These are example problems from Chapter 6, Lesson 1, and it's an introduction to percents. So let's take a look at the percent symbol real quick, and we'll get an idea about what percents are just from the symbol itself. If we take this symbol, the slash right here represents a fraction bar. The two zeros here represent 100, the two zeros in 100. And a percent basically is a number over 100. And so that's what we are going to be dealing with. So when we look at the first set of directions, it says write the percent modeled by each grid. So if you look at how many little boxes we have all together, let's count them up. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we got 10 going down this way. And we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 rows and 10 columns. And so if we took 10, multiplied it by 10, that would give us 100. So what we have is 100 squares. And so what we want to know is how many are filled in. What is the percent modeled by this grid? So we want to know the number, the filled squares, the filled out of the total. And the total happens to be 100. There's 100 squares. So we now just need to figure out what the number of filled in squares are. So if we look at this one, there are 1, 2, 3, and then there's 3 going down. 1, 2, 3. So there's 3 up there. And so that means 3 by 3 means there's 9 altogether here. Count these up, we got 1, 2, 3, 4, 5 by 1, 2, 3, 4, 5. So 5 by 5 means 25 total. And then over here we have 1, 2, and then 3, 4. So 4 total. And so all we're doing is just adding up those numbers. So that's 9 plus 25. And so just add up these numbers, 9 and 25 plus 4. And so right here, the 9 and 25 gives me 34, plus 4 gives me 38. And so there it is, 38 out of 100. And a percent, again, is a number over 100. And so we would write that as 38%. And there is our answer. So again, all you're doing is figuring out how many filled in squares there are and writing that over 100, because there'll be 100 altogether. And that's what a percent is. It's a number out of 100. And so what we want to do on the next set of directions is write each percent. So they're giving us the percent as a fraction in simplest form. Well, we're going to use that same concept of what a percent is. And a percent is a number out of 100. And so if we take a look at this first one, 16%, well, that's the same thing as 16 over 100. And so what we want to do from there is put it in simplest form. So simplest form, this means we need to reduce. So reducing fractions, we need to use divisibility rules. So I wrote some divisibility rules up here. And these are important ones for you to memorize. Definitely memorize the 2s, 3s. I'd memorize 5s, 9s, and 10s. 6s and 4s are good ones as well, but if you can memorize the 2, 3, and the 5 and 10 and then 9 as well, life will be a whole lot easier. So let's take a look at one of those rules. One of the rules for 4, and this is one that isn't as important because you can always divide by 2 and get that eventual number. See, for the rule for 2 is that if it's an even number, so it ends with a 0, 2, 4, 6, or 8. And so that's what we have here. So 2 goes into these numbers. But we can also do 4. So the divisibility rule for 4 is that the last 2 digits 4 can go into. So looking at this one here, see 12, 4 goes into 12. Well, this rule is okay as long as the number is not really big. And then it becomes a little bit more challenging, like 72. Do you know if 4 goes into 72 or not? Well, here we have 16, and here we have double zeros. Well, anytime you have double zeros, 4 goes into it as well. That's one of the things that this rule doesn't show us, but it does. So what I'm going to do is I'm going to reduce this by dividing by 4, because I know 4 goes into those two numbers. And so when I do that, I end up with 4 over 25. And that is the reduced, simplified form for that number. Fix that 25 real quick. Well, let's take a look at the next one. We have a 49%. Well, same sort of thing. All you're going to do is write the number over 100. That's what a percent is. It's a number, 49 over 100. Well, then you try to reduce it, but the only number that goes into these two numbers is 1. Well, we don't have to worry about dividing by 1 because that won't change anything. So that would be our answer right there. Well, the next one, remember, a percent is just a number over 100. So we write 20 over 100 and then reduce. So if you don't see the biggest number at first, just start with the small ones. So let's say you didn't see 4 goes in there. Let's say you didn't see 5 goes in there. Let's say you didn't see 20 goes in there. You could start with 2. So we could reduce by 2 to start off with because they're both even numbers, and we'd eventually get there. See, this would be 10 over 50. And then you see, oh, well, I see they both end in zeros, double zeros. That means that 10 goes into it. See, if 10 is if the last digit is 0. Well, we could go ahead and divide by 10 now and eventually get there. So just because you don't see the biggest number that goes into that answer, well, it doesn't mean you can't get it in simplest form. Eventually you'll get there as long as you don't make any division errors. So 1/5 is the answer for this one. Well, here's another one, 56%. Well, again, it's just 56 over 100. And again, if you don't see the big numbers that go into them, start with what you do know. That's why 2 is a great one to memorize. You know, if the digits are even, if they end in an even number. So 6, 0, those are both even numbers. See, if you don't see the bigger numbers that go into them, start with 2. And eventually you'll get down there. So if we do that division, we end up with 28 over 50. And so from there we can reduce further. We could take out another factor. See, 2 goes into it again. So if you didn't see the bigger number, you could go with 2 again. And so we can divide by 2, and we end up with a 14 over 25. Well, actually, that's as far as it goes. Couldn't go any bigger than 2 in that case. So 14/25 would be our answer. Well, let's take a look at the next set of directions. It says to write each percent as a decimal. Well, how do we do that? Well, let's take a look back at what a percent is. A percent is a number over 100. So we've got a percent equals a number. We just don't know what the number is. It could be anything. It could be 33. Doesn't really matter. It's 33 out of 100. And so if we write that, let's write that as a fraction real quick, 33 over 100, we're dividing by 100. And so every time, no matter what the number is, you're always going to divide by 100. Well, let's see what happens if I do that division. And then we'll come up with a rule to be able to do it every time. So let's see here. If you're stuck, always do this. Always go back to what you know. So if we have a fraction, remember, top dog goes in the doghouse was the little saying I've heard before. So you see that 33 is the top dog. He went inside this doghouse. The 100, well, he's the bottom dog, so he goes outside. And so when we do the division, let's see what happens. Well, I've got to add a decimal point, and I got to add a 0, and then I got to start doing the division. How many times does 100 go into 330? Well, that'd be 3 times, and I have to move that decimal point up, and I end up with 300. I'll go ahead and do the subtraction, and I have to bring a 0 down, and now I have to do 100 into 300. Well, that goes 3 times evenly. So we got our answer there. You see, we've finished off the problem. It makes 0.33. So 33% equals 0 and 33 hundredths. Well, what they do is if we are dividing by 100, we're going to get the same exact digits. The difference is the decimal point. So take a look at where the decimal point is on a number. If you don't see it, it's always right there, right at the end of the number, to the right of the last digit. And it moves over the number of zeros we're dividing by. So 2 spaces, 1, 2, and that's where the decimal point goes. Another way I always remembered, or I was told by my teacher, was the number of zeros in the percent sign. See, there's 2 zeros in the percent sign? That's the number of spaces you move the decimal. Well, it works with this one, so let's just go ahead and practice that division just to see how it works again, and then we'll go ahead and go with the rule as well. So again, the number 13.2% is just 13.2 over 100 every time. It never changes. A percent, no matter what the number is. It could be 5,000%. It's still over 100. Well, from there, we're going to take that 100, and I'm going to divide. The top dog, again, goes in the doghouse. 100 into 13 2/10. Well, the decimal point comes straight up in the problem, and I do 100 into 132. Well, that goes one time. So I do the subtraction. I get 32. I got to bring down a 0. And I do 100 into 320. Well, that goes 3 times. And I get 300. Do the subtraction. I get 20 left over. I bring down another 0. And now it's 100 into 200. 2 times evenly. And you're done, because you have a 0 as the remainder. Well, we've got our answer here. It is 0 and 132 thousandths. Well, let's see what we could have done. See, the digits are all the same. Look at those digits. We've got the digits of 1, 3, and 2. Here we have 1, 3, and 2. The decimal point's the only thing that moved. And what we're doing is when we divide by 100, see those 2 zeros here? It moves the decimal point 2 spaces. The numbers stay the same because of the 1 here, but the decimal point moves because we're dividing by 100. And that's what we do. We just move that decimal point 2 spaces. So let's practice this. Let's see if the rule ends up working for the other ones as well. Let's just try this rule. Let's see. If we go over 1, 2 spaces, see we have to add a placeholder here of 0. We're predicting it's going to be well, here I'll put the 0.0116. So I move the decimal point 1, 2 spaces over. Let's see if it actually ends up working. So I take that number, 100, and I'm going to divide it into 1.16. So I add the decimal point. 100 does not go into 1. It does not go into 11, but it does go into 116 one time. That makes 100. Do the subtraction. Add the 0. 100 goes into 160 one time. And then I do the subtraction again. I get 60. Add a 0. Bring it down. 100 goes into 600 6 times. There's my answer. And see, again, that makes 0 as the remainder, so we're done. But look at the answer. It matches what our prediction was. So it works. So all you have to do is move that decimal 2 spaces, and you've got your answer. So same thing on this one. Move it 2 spaces, 1, 2 spaces, and we should have our answer. So the decimal form of 27 5/100% is going to be 0 and 2,705 10,000ths. And that's going to be our answer. And so we've got time to prove it. Let's go ahead and do it. Let's put that 100 on the outside, and we'll put the 27 5/100ths inside. Bring that decimal point straight up and do the division. See, 100 does not go into 7, does not go into 2, does not go into 27, but it does go into 270. It goes in there 2 times. So that makes 200. And we bring down the 7, the 0, and we bring down the 5. So we go ahead and bring that down as well, and we end up doing, let's see here, 100 into 705, and that ends up going in 7 times. And so we go ahead and do some multiplication. We get 700 there. We subtract. We got 5 left over. Well, I got to bring down a 0. Oh, it doesn't go into 50. So we got to put a 0 there again as a placeholder and carry down another 0. 100 into 500 goes 5 times. So there's our answer. We did it. We got a remainder of 0. And there's our answer. It matches what we predicted. So again, when you're moving percents to decimals, just moving that decimal 2 spaces to the left because you're dividing by 100. And the symbol, the percent symbol, gives that away. It shows us that we have a number over 100, or we're moving that decimal 2 spaces. That's what the 2 zeros represent. So good luck on tonight's homework.